Hi, I'm Cheryl Leach. In this problem, we're being asked to find the indefinite integral and then check our result by differentiating. Well, let's take a look at my integral. It's fairly complicated, and one option I would have would be to multiply it all out and get a large polynomial, then use my basic rules. This would be very complicated though, so let me see if I can think of a better way to do it. Well, I know that integration and differentiation are inverse processes. And when I look at this particular integral, I see a composition function. And when I think in terms of differentiation, that makes me think of the chain rule. So is there a way to undo a chain rule? Well, let's go ahead and look at something called the general power rule. If you're integrating u to the n times du dx times dx, we know that that integral is going to be u to the n plus 1 all over n plus 1 as long as n does not equal -1. And of course, don't forget that constant of integration as well. Well, I want to see if I can get the problem I'm given to fit this form. Well, let's see. I need a part that's raised to a power. I'm thinking that's going to be my 2x cubed minus 1. So let's begin by letting u equal 2x cubed minus 1. I'm also going to need a du dx. I can get that by differentiating my substitution. So du dx is going to be 6x squared. Now let's see if I can find these two pieces in my given integral. Well, I think I'm going to switch the order that these things are written. Remember, multiplication is commutative. I can write it in whatever order I want. So I'm going to write this as 2x cubed minus 1 to the 4th power times x squared dx. Well, here is my u to the n that I want. N is going to be 4 in this particular case. But my du dx isn't quite right. I want a 6x squared, not just an x squared. There's a common trick in mathematics when we want to rewrite an expression, and that is to multiply by 1. But 1 will take on a more advanced form. In this case, it's not too bad. It's just multiplying by 6 and multiplying by 1/6. So if I do that, I'm going to multiply by 1/6 and then multiply by 6. So what's happened? Multiplying by 1/6 and 6 means I'm only multiplying the expression by 1. Nothing has changed. And so here I have my u to the n that I want, but I also have my du dx that I want. So I can pull out my constant of 1/6, and then my rule tells me all I have to do is take that expression, 2x cubed minus 1, raise it to the 5th power, and divide by 5. And of course, tack on that constant of integration. With some simplifying, I find that this is 1/30 times the quantity 2x cubed minus 1 to the 5th power plus c. All right, I'm fairly confident in my answer, but because this is a new process, it's a good idea to check our answer. And we know you can check your answer by differentiating your result. So let's take a look. I'm going to take the derivative of 1/30 times 2x cubed minus 1 to the 5th power plus c. Well, first and foremost, I have an addition problem, so I'll differentiate each piece individually. In the first term, I can pull out that common factor of 1/30, and now I'm going to use the chain rule on this piece. So I'll bring down the 5, copy over the x cubed minus 1, subtract 1 from the exponent, and here's where the chain rule comes in, times the derivative of my inside piece, which is going to be 6x squared. The derivative of my constant is 0, so that doesn't add anything else to my problem. So let's see. I've got 5 times 6 all over 30. Those are all going to cancel, and I'm left with 2x cubed minus 1 to the 4th power times x squared. Now, if you look at the original problem, the integrand was exactly the same thing. Again, the order is reversed, but multiplication is commutative, so that's not an issue. I hope this was helpful. Thanks.